Let's take a look at a couple more examples with an increased difficulty level. Here we have x squared plus y squared plus 5y plus 2 is equal to 0. Well, we go to group our x's, but there are no other x's. Okay, fine. That's actually good news because x is already a squared, so no need to worry about anything going on with the x's. We do have some y's. We'll group those together. And we'll move our constant term to the other side. Okay. Remember, x is already a perfect square, so we don't need to do anything with that. We'll take half of 5, and we'll get 5 halves. We'll square that, and we will get 25 fourths. So we'll add 25 fourths here, and then on the other side of the equation as well. Now when we create our equation, when we do our factoring, x squared is just a perfect square by itself. No need to factor or anything. That's x squared plus the y factors into y plus square root of this is 5 halves. And negative 2 is negative 8 fourths plus 25 fourths becomes 17 fourths. Okay, so the center of this circle, well, if there's nothing being added or subtracted to x, what does nothing translate to as far as adding and subtracting in mathematics? 0. And that's plus 5 halves, so we have negative 5 halves. Our radius will be the square root of 17 fourths. I am able to take the square root of 4, it's 2, so that's going to be square root of 17 over 2. In this last example that I'm going to do on the video, we have 2x squared plus 2y squared plus x plus 6y minus 9 is equal to 0. All right, we'll group our x's. We'll group our y's. And we'll move our constant term to the other side. So I'll add 9, and we have this going on. Well, we have the situation again where the lead coefficients are not 1, so they're 2. So I have to factor out a 2. 2 times what gives me 2x squared? That's just x squared. Now I need 2 times something to give me a 1. That's an understood 1 there. If you need some help thinking through it, just write yourself a little equation. 2 times what, you could certainly use a variable. We are trigonometry, we can use variables. 2 times what gives me 1. If I divide by 2 on both sides, the what is 1/2. All right, so plus 1/2 x, just double check it. 2 times 1/2, that's 1. Okay, we're all good. Factoring a 2 out in the y's is not nearly so complicated. 2 times what gives me 6? That's going to be 3. Doesn't affect the constant on the other side. Time for some completing the square. Half of a half is a fourth, and a fourth squared is 1/16. So I will be adding 1/16 here. Notice there's the 2 on the outside, so the 2 is multiplying 1/16. 2 times 1/16 is 2/16 or 1/8, so I will add 1/8 over here on the right hand side to balance out my equation. Let's take a look at our y's. All right. Half of 3 is 3 halves. 3 halves squared is 9 fourths. So I will add 9 fourths. We have a multiplier again. 2 is multiplying 9 fourths, so that's 18 fourths or 9 halves. Gets added to the right hand side. Time for some factoring. With this first set of x's and the x part, we have 2 times square root of x squared is x. Keep that sign plus 1/16 square root of that is 1/4 quantity squared, plus 2 times square root of y squared is y, sine of the middle term, square root of the last term, and that's equal to, so 9 plus 1/8 plus 9/2 over 8. That's a 0. I'm close. I need to divide by 2. I can put that as divide by 2, but when I've got a fraction, I'd much rather multiply by 1/2. So we have x plus 1/4 quantity squared plus y plus 3/2 quantity squared is equal to 109 over 8 times 1/2, which is the same as dividing it by 2, is 109 over 16. Okay? Remember, our task was to tell the center and the radius of each of these circles. This circle would have a center at -1/4, -3/2, and a radius, we would take the square root of 109 over 16, which would be equal to the square root of 109 over 4. When these notes are posted, I will also have completed these other 2 examples over here for you to take a look at, so I encourage you to try them on your own and then check them with the notes.